Hello, dear friends. In this video, we are going to see about retrievers in LangChain. Also, we can say in the RAG. So we know that retriever is an important concept in the RAG. So we saw in the previous video how to use RAG along with the LangChain and all. We saw an example. So here we are going to basically see about retrievers in the RAG. What is retriever means? We know that LLM is already pre-trained in some documents, maybe website, law, a huge number of books and all. But if you have some certain domain-specific questions, or if you have some factual questions, it may not be properly answering. It may lead to a hallucinated answer, something like that. So we cannot always trust those answers. So we want our application to be grounded to external resources to get a more accurate result or to get a more domain specific answer. And also we want an accurate factual data, so we want some external grounding information. So whenever a user is asking any query, it want to retrieve that information from the documents attached the external ground. So to the retriever is going to fetch that relevant information based on the input or the query gave by the user. So the retriever is playing a major role in fetching the relevant document from the externally grounded resources. It may be a PDF, may be a Wikipedia or any other external resources which we have grounded along with the RAG. So there are many kind of retrievers are there: vector retriever, KNN retriever, custom retriever, external retriever. So KNN retriever means, we know in machine learning you might have learned about KNN, that is K nearest neighbor, right? So here also K represents how many nearest neighbor to be considered when we retrieve an information from an external document. So here I have specified the K value as 1. So, and I'm creating an object for the retriever. And when the retriever, here I am asking a query given by user, that is on AI. So it was going to get the relevant information with one nearest neighbor. Since I gave the k value as 1, it is going to take only one nearest neighbor. So here, and when we print it, I will be getting AI means only one. A is the feature. So I'm asking 1. If I asked 3, it will give 3 nearest neighbor values, which is relevant to AI. So this is what K in a retriever. And the next one is PubMed retriever. You might have heard about it. So whenever you want some information related to biomedical literature, the some information related to the journal, so in the PubMed, so we can use this retriever. So this is, you know, that PubMed is the world's largest biomedical research database. So when we want some information from there, we can use this retriever so that it will go and take the relevant information from the PubMed and it will give it to us. And the next thing, one is Wikipedia retriever. So we know that Wikipedia is a knowledge base. We get some particular information or particular any kind of data, details, information we can get from that. So Wikipedia retriever will fetch information directly from that particular Wikipedia article. It's something similar to PubMed. PubMed, how we use the PubMed retriever to get the information related to medical literature. So here also we can use this public knowledge base to get relevant information. Next one is vector retrieval. So it is embedding based. So this vector retrieval search, we know already, we have learned in the previous video what is vector, what is live vector library database and everything. So this vector retrieval search a document using semantic search. So it is basically used in RAG-based chatbot, and here it uses embeddings plus vector database. So instead of searching exact word, for example, AI is different from artificial intelligence. So if we search by exact word, this both, even though both are similar, we will not get the result. But if you search based on the meaning, you will get the relevant information. So that is about vector retrieval. And we have many API retrievers also. So the API based. So whenever we want some weather information, we can use weather API, PubMed API, we can use news API. We want the latest news, means we can go for it. Whenever we want knowledge base from Wikipedia, we can go for Wikipedia API. So similarly, we can get the relevant information. The next one is database retrieval. So whenever we want information from the structured database like MySQL, SQL or PostgreSQL, we can go for it. Like for example, whenever we want a company chatbot retrieving some information from their database and to provide it, we can go for this kind of database retrieval. So remember, retrieval means it is going to the particular resource attached and get the relevant informations. So that is the job of retrieval. So the agent is like orchestra, which means it is going to arrange all the process. So LLM is like it performs the reasoning and it will actually choose the tools required for the particular input. So both are involved in the different roles. So A is like agent is like a manager. LLM is like a brain. It only thinks and it will understand what kinds of tool it required. For example, if we want some weather information, it will inform us. Okay, go and choose like weather API. Or if I want some medical literature data, then it will suggest us to use this PubMed retriever. Like that, LLM is like a decision maker. Agent will execute it. That is a manager. And the tools are like the workers. So calculator, if you want, we can go and use a calculator. Or like a database needs, it will go and use database to retrieve the information. So accordingly, it will perform. So here is clear a differentiation between agent and the LLM. What is the role of agent and the LLM? So whenever the user is giving some query, the agent send that to the LLM, including the user's questions, tool description, everything will be given to the LLM. The LLM only now think and it will say, okay, it needs a calculator to perform all these things, or it need PubMed API or a database API, whatever it may be. And then the agent will read the LLM output and then it will execute the particular tool. So even it can be a calculator or API or any other external tools. Then it will be executed. The tool will be then getting the result and send the results back to the agent, and then agent will be sending the result back to the LLM, and now LLM generates the human-like answer. So LLMs is always like taking the decision, but agent perform the actions. So LLM is like a brain and agent is like a body. So brain thinks and who is doing all the activities, hand, mouth, leg, all those things. So execution is done by the agents. So LLM directly cannot go and click a button or do or run a script. So this all can be done by the agent. So agent is like a software what reads the text and carry out the commands. So the decision making process, when we see who does which job role, the responsibilities, LLM is like a decider. LLM will analyze the prompt, it will realize, and it doesn't know the answer, but it select the tool for it. For example, it doesn't know the answer from the medical literature, but it know where to get this data. It will suggest us to use the PubMed aid retriever. Or if it want to do some mathematical calculation, it will suggest, okay, use calculator. So that can be done by the LLM, the decider. And who is going to execute all these things? Okay, as per the suggestion by LLM, the agent is going to take the action. So it will like use the calculator and then you whatever use the PubMed API and it will execute it. Then the tools will be doing their job and then it will get back the results given back to the LLM. Agent give the results back to the LLM and LLM will be responsive in a human-like manner. So now let's see some small demo for it. So here I have uploaded one of my PPT. This PPT is uploaded here in the, sorry, this PPT is uploaded here in a form of a PDF. And so you can see here, I have using Pi PDF loader. Here I have loaded this PDF, Introduction to Generative AI. And now using this load function, I'm taking the content which is available in this PPT or this PDF, which I have uploaded in that format, is now in documents. Now the total length is like 10 slides. So 10, so it's considered as 10 documents. And now from the zero to document first page, I'm going to ask the first 500 character content. So if you see in my slide, so this is the first one. So it says, okay, here it is. Introduction to Generative AI. and it says a beginner's guide, so that it is here, and discover the revolutionary technologies, that is here. So from the document, it has read the first 500 characters. So this is like loading the data using the PDF loader. So we know that here, whenever we do embedding, it is not directly the entire content is converted to embedding. Instead, it will be splitting the content into chunks. So here I have used recursive character text splitter from LangChain. So that is going to split the document. So I'm asking the chunk size is 500. And we know that yeah, the whole document is going to be chunked into 500, 500, 500. And the last 50 characters from the first chunk and the first 50 character from the second chunk will be having the same content, so that we can able to link with one another. Similarly, the last 50 characters of the second chunk and the first 50 character of the third chunk will be having the similar data, so that we can able to connect one chunk with the other chunk and we can relate it. So based on this configuration, now this document where we have the content from that video is now a splitter and it is in docs. So now the total length is 19. And then again, I'm asking from the zeroth document, and I'm getting the first 300 characters. Same thing is displayed because it is chunked. Right, the same way. Now we are going to, after we get the chunks, what is the next step we do? The chunks are now converted into numerical representation. For that, from the Hugging Face, we are using this all mini LM L6V2 sentence transformer model to do the embedding, which means for the numerical conversion. And now after I get this model is now ready. Now the docs, no, what is docs? Here I have the chart data. So now the doc is going to be embedded. So here you can see using the files we have already discussed in the previous videos, right? What is vector storage and all. So this is a vector library, and from that I'm going to store this embeddings as well as the vector store. So here this way embedding, I'm going to use this embedding to embed this document, and I'm going to use as a temporary storage using this files. Now I'm going to create a retriever. So, and I have the retriever object here using this vector store. I'm going to, from this, this is now going to be considered as an external resource. From this, we are going to create a retriever object. And now from this, we can able to get any data. So this is how a process will be happening. So loading, splitting, embedding, and stored in this. For demo purpose, we can go for this vector library instead of vector database. This thing we discussed in the previous video. Hope you have checked it. Now we can able to, and then we know that we can use a template, give that, get the context and give that to the chain LLM and the prompt, and the retriever. Already we have stored the document. We'll get the data from this LLM and the prompt is given. And then this chain, so for this, we are giving an input models of generative AI. So from this PDF, no, this PPT is converted in the form PDF and uploaded. So it will find the model, the information. And then if you see in the output, you can see the models is displayed here. The models of generative AI is what I have asked. So from that, it has taken and it has displayed here. So that's all about. And if you want document by document, it is showing here. Now let us go directly to the retrievers. So, okay. So again, the same thing. PDF loader is used to load the document from the PDF, and it is in the document, and the first page content is displayed here. You can see the first page content here on the basics. So what is generative AI? So this content is now retrieved here because I'm asking the first document content. So now let us go onwards. We have in the PPT, I have just explained about the KNN retriever. So same thing, I'm asking for one nearest neighbor. So I'm giving the input as AI. So from the document which we have uploaded, it is going to find the one nearest neighbor document. So it is giving AI is the feature. So similarly, PubMed retriever. So first I'm going to install or use this from the LangChain retriever, I'm going to use this PubMed retriever. So using this PubMed retriever, we have to give this email, and so we have to give some email, and then I'm asking for the top five searches. So PubMed retriever will give us the top five. So you can see 1, 2, 3, 4, 5. So from the PubMed, it will be generating the answer relevant to what I'm asking for the cancer treatment. It is finding using the PubMed retriever, finding the relevant document, it will give us. Then next one is Wikipedia retriever. So similarly, from the LangChain community retriever, we are downloading or importing the Wikipedia retriever, and then I'm creating the retriever. For the artificial intelligence, I'm asking for the top two result. So we can get the top two results from that. So here is one, and here is one. So from the Wikipedia related to artificial intelligence, it has retrieved the document. Similarly, using the vector retrievers like face. So here I have a text using a Hugging Face embedding. We have embedded, and using this vector retriever, we are getting the one nearest neighbor, and I'm asking what is AI, and it's giving the answer to me. AI is improve the automation, something information is retrieved. So these are the retrievers, and API retrievers are here. So it can be dynamically, according to the information which we ask, it will dynamically choose the particular retriever. So news retriever. So from the news retriever, it will go and get it. So these are the different retrievers we can use according to the purpose. So agent can decide based on the input given by the LLMs. So hope you have got it. Thank you. Thank you for listening. God bless.